Alrighty, folks. Today we are going to be talking about mechanical advantage, which is ultimately how simple machines affect the work we do with them. So, what we're basically going to talk about today is why is it that you could never ever even bend a bolt. But if you use this tool right here, a bolt cutter, you can actually cut a thick piece of metal like a bolt. So why is that? Well, the answer is mechanical advantage. Let's learn a little bit more about that. All right, here's our agenda for the day, folks. I want you to go ahead and make sure that you take Quick Quiz 3.3, which is going to count as your attendance for the day. After that, I want you to go ahead and set up your notes. Our topic for today is mechanical advantage, and our essential question is, how do machines affect work? After that, we're going to go ahead and take notes on mechanical advantage, and at the end of all of this, I'm going to want to make sure that you complete the simple machines diagram that we are going to fill out today. So go ahead and pause the video, take your quick quiz, and get your notes set up, and then come on back. All right, our learning target for today is I can demonstrate how mechanical advantage affects work. All right, so let's start off with this. We talked about machines the other day, and specifically simple machines. But what we're going to do now is we're going to connect those machines to the work that they do. So, as we said before, a machine is a tool that increases the effect of human effort. And if you think of human effort as work, that's basically going to be that it changes that work that is done. So, when you have a machine of any kind, you have two types of work. You have work input, which is the work that you put into a machine. And then you have work output, which is the work done by a machine. So let's go ahead and look at this example here. We have a hammer and a nail. So actually we're dealing with a couple of simple machines here because a hammer is actually a lever. And so the work that you put in is what you are doing with your hand and arm with the hammer. So you put in that work. So if you imagine you're holding a hammer and you're flipping your wrist, that is the work you're putting in. The movement of the hammer itself, that is going to be the work output. That is the work done by the machine. And oftentimes, when you are working with a hammer, you are trying to hammer a nail into something. And a nail is another example of a type of simple machine. So that work output from the hammer, which is the head of the hammer swinging down, that becomes the work input to our nail. So you have the work output going here, and then the work input is the force that goes down on the nail. The work output by the nail is then what the nail does to the wood, which is splits the wood and allows the nail to go down into it. So that's the work output, or the work done by the wedge of a nail. Now, we also need to consider something, and this happens in physics a lot of times when you're dealing with these concepts, and that's the idea of ideal versus actual. So in reality, anytime you do work with a machine, some of that work is going to be lost to things like friction, which then becomes heat, and maybe some of it's going to be lost to sound. So think about if you take a hammer and you hit a nail really, really hard, really, really fast, it's going to make a lot of noise. And then also if you felt the nail after that, especially if you were trying to hammer it through a piece of wood and then you could feel the bottom of the nail would feel really hot. And that's because the work that you did on the nail, friction was involved and sound was created. So in reality, the work output is going to be less than the work input in the actual world. However, for the sake of simplicity, we're going to stick with what is called the ideal. And we're going to pretend that you don't actually lose any work that is done. So this is just trying to kind of simplify things and making it a little bit easier and more straightforward to understand. So we are dealing with the ideal situation, and we are just going to say, for the sake of simplicity, that work input is the same as work output. What question does the previous slide answer? All right, so all of this is to get us to the topic of mechanical advantage. So ultimately, machines make work easier. Otherwise, why would we use them? And so the way that machines make work easier is called mechanical advantage. And what that means is it is how a machine changes the work input. And so while the work input and work output are equal to each other, that doesn't mean they're exactly the same. Let's go ahead and go back to our mathematical definition of work, which is force times distance. So what we are saying here is that this number here, the work never changes. However, the components of the work do change because you can change the force and that will then affect the distance as long as the work stays the same. So if you increase the force, that means you have to decrease the distance. If you increase the distance, that means you have to decrease the force. And that's what a machine does. It either increases the force or increases the distance. And so we are going to focus on what is increased, but do realize that whatever is increased, the other is decreased. So the first type of work that can be done, or the first type of mechanical advantage we can have, is an increase in force, which means that there is a decrease in distance. So this would be an example of bolt cutters. So if you have bolt cutters like this right here, if you open up the bolt cutters here on the handles, when they're fully open, the handles will probably be about, 60, 70 centimeters apart, which is about 2 feet, okay? And when this is all the way open, the tip of the bolt cutter here, it's only going to be open about 2 to 3 centimeters, or about an inch. So what happens then is you, on your side, you push closed the handles of the bolt cutter, and then that forces the blades of the bolt cutter here to close as well. Well, your hands traveled a huge distance to close that gap between the handles, but the bolt cutter itself, the blades up here, they only traveled a tiny distance, but the work done at both ends was equal. So what that means is that distance was made up for by increasing the force, which is why that part of the bolt cutter right there, it can cut through a pretty thick chunk of metal like like a lock or a bolt itself. And so in that example, we are increasing the force. The output force is increased because the distance has been decreased. Pliers are another example of that. A car jack as well. If you've ever been in a car that got a flat tire, you'll know that someone went outside and they put a car jack under. And in order to get a car jack to raise up, it kind of uses a wheel, an axle, and a screw, and you go around and around and around and around and around and around and around, and the jack very, very slowly raises, just super slow, and it takes a while to get the car jacked up. So the jack itself, the distance is very little, whereas the distance your hand is traveling, your arm is traveling, is very high. So because it's moving the jack itself is moving so little, that means the force with with which the jack is moving is very, very high. So we have increased the force. Now, the opposite can also be true. You can increase the distance while decreasing the force. So, for example, a baseball bat. If you think about a baseball bat, when you swing it, you are actually, as you are swinging it, the work that you are putting in a less distant, or a certain distance, but the end of the bat itself is swinging over a larger distance. And so what that means is that the end of the bat has a mechanical advantage that it increases the distance, which seemingly this maybe doesn't quite seem like it, but it is true. That means that the end of the bat also is decreased the force from your original swing. But because you are increasing the distance, that means that you have more distance where you can hit the ball itself. A bicycle wheel is an example where you increase distance because you turn the axle. So you turn your pedals, which turns the axle, which is the small part of the wheel and axle. And that axle is turning with a lot of force, but it's turning a small distance. But that little distance that's moving then gets turned into a bigger distance in the wheel. And a boat oar is similar. If you've ever rowed a boat, you pull the oars just a little bit with a lot of force. But if you go outside, or if you look at the other side of the oar itself is traveling a huge distance. And so it's an increased distance, but with less force. A mechanical advantage can also be that you change direction. We'll talk about this with pulleys, but if you pull down on a pulley, the load goes up. In a teeter-totter, one side goes down, the other side goes up, and a boat oar actually also changes distance, or changes direction. What question does the previous slide answer? Alrighty, folks, I want you to go ahead and open up your packet, and you are going to find a diagram that looks like this, a graphical organizer, I guess I should say. And what we're going to do is we're going to go through the different types of simple machines, and we're going to draw a diagram of those machines and describe the mechanical advantage of each of those. So this is going to take a little bit, but I want you to follow along and pause whenever you need to and make sure you have a completed diagram, the mechanical advantage, and the example. Everything will be on the slide for you. All right, so first things first, we're going to talk about levers. Now, you do not need to be able to tell me the 3 types of levers and identify whether it's a type 1, type 2, or type 3 lever. Instead, you should be able to look at a diagram of each type of lever and tell me what is happening. So don't get caught up on understanding type 1 versus type 2, type 3. It's more important to me that you just understand there are 3 types of levers. So this is a type 1 lever. You have the fulcrum in the middle here. You are pushing down on one side of the lever, that is your input work. And then on the other side of the lever, it is pushing up, and so that is the output work. And the main mechanical advantage of this is that you are going to have an increased force. So you'll see that this side of the lever travels a much greater distance, and this side of the lever travels a lesser distance, which means that this one has a much higher force. And so our example of this is a screwdriver opening a paint can. If you take a screwdriver and you stick it here under the lid of a paint can, it rests on this little lip right here, which acts as our fulcrum, and you push it down and you move a great distance with your hand, and the little tip of the screwdriver only moves a small distance, but it moves with a lot of force, and that opens the paint can. Next is what's called a type 2 lever. A type 2 lever, you have the input force and the input work and the output work on the same side of the fulcrum. And what you'll see here is because this part of the lever is moving a farther distance for your input, the output moves a lesser distance, which means that it moves with more force. Our example of this is going to be a wheelbarrow, where the actual entirety of the wheelbarrow is the lever, and the wheel is going, I guess that would make that the barrow. So the barrow is the lever, and then the wheel is the fulcrum. And so you lift here and you move a pretty decent distance, but that allows you to move a heavy load because you push up with a lot more force and you can lift a lot heavier load in a wheelbarrow. Your third type of lever is a type 3 lever, and in this case, the fulcrum is up top here. We're doing more of a vertical, and your input is below the fulcrum, and then your output is even lower than that. So think about a hockey stick. So when we're swinging a hockey stick, your top hand is going to be the fulcrum. Your hand that is actually doing the swinging, where you kind of get your power from, that is going to be the input work. And then the output is going to be the stick itself. So in reality, you're actually, there's more force in your hand, but the lever, the output, is actually moving a greater distance, and that allows you to more easily strike the puck. And so the mechanical advantage of a type 3 lever, which is our example is a hockey stick, is that you increase the distance. Next, we have a wheel and axle, and there are 2 ways for wheels and axles to have mechanical advantage. And our first way is going to be if the wheel is the input and the axle is the output. So a quick reminder, wheel and axle is made up of 2 discs or cylinders where the wheel is the larger of the 2, and they turn together. So in this example, we are putting our input work into the wheel and the output is the axle. Now, because the wheel is larger, that means we're going to be moving a greater distance with our input, and our output is going to be moving a smaller distance, which means that it is going to have an increased force. Examples of this include something like a screwdriver. So the screwdriver, the handle is the wheel, and the shaft is going to be the axle. And so the handle actually has to move a greater distance than the axle does, or than the shaft of the screwdriver, meaning that the force applied by the shaft of the screwdriver is going to be increased from the force put into it. A steering wheel is similar, where you turn the big wheel and then that turns a shaft that has a lot more force to cause the wheels of the car to move. Now, the opposite can also be the case, where the axle is the input work and the wheel is the output work. So in this example, you are turning the small axle, and that means that you are turning the large wheel as the output. In this example, then, you're doing very little distance with a lot of force moving the axle, and the wheel itself is moving a much larger distance with less force. So your advantage here is going to be you increase the distance. So car and bike wheels are an example of when the axle is the input. So look at this right here. You see this bike, you have your axle right here, and so you pedal, and then that turns the axle, and that axle is turning with a lot of force, but it's only turning a tiny distance because the axle is so small. The wheel then, it is moving and rotating, and it is increasing the distance, but it is acting with much less force. So the advantage here is that we increase our distance and we can travel really far on a bicycle. Incline plane. All right, so in an inclined plane, what we are doing is our input work is going to be the distance that we travel up the ramp itself, and the output is how high we end up getting. And so the mechanical advantage here is that we are actually increasing force by allowing ourselves to travel a greater distance to get up here. So if you look here, this stoop is kind of, I don't know, maybe about a meter off the ground, and you could just kind of jump up there, but instead what we do is we travel a greater distance, and as a result we are able to move up there easier because that force is being dispersed over a larger distance. And so our result here is that we have an increased force. Highway ramps are another example of this. A wedge. So a wedge is going to be, as we said, two inclined planes pointed together in a V. And so for a wedge, the mechanical advantage, so you put the work input goes pushing down on the wedge in this example. And so what is going to do is we're going to push down on that, and the input force is going to, or the input work is going to come through the wedge, and it is actually going to then go in two directions, both directions pushing away from the wedge. And so the advantage of this is that you move a great distance in order to push down on, or for the work to move the wedge. And then that distance is then turned into a greater force, which allows you to split wood. So if you think about it, you swing an axe really hard and you're moving a great distance. And when you get to the wood, you actually don't move that far. But what you do is you split the wood because the force is increased. So all that distance you traveled for the work, then you travel a very little distance for the output. And the force is what is important because then that splits the wood. And the same is true of a knife and nails. A screw. So in a screw, what we are doing is we have an inclined plane around a shaft. And what happens is our input is this rotation up here. So we rotate with a screwdriver, and the output work is that the screw goes straight down. So in this example, because we're doing that, we are putting a lot of distance when we're doing our screwing. So you move the screw a lot rotationally, and it really only goes down a very little amount compared to the rotational distance you put in. But it's moving with an increased force, so it is able to be more powerful and go into things like wood and split that wood and then get in there. Nuts and bolts, this advantage can be used to put nuts and bolts together and hold together really heavy objects. So screw increases force. All right, for the pulleys, we have three types of pulleys. The first is what's called a fixed pulley. In this example, this pulley right here, so our wheel with a groove in it, the pulley is attached to a fixed surface. And what we are then doing is the rope runs through it, and we pull on one end of the rope, and that is our input force, and the output force is the object moving the opposite direction. So in this case, your input and output are going to be equal. It's just that it's going to be the opposite direction. So a fixed pulley changes direction, and that's its mechanical advantage. Examples include a flagpole pulley. So this guy right here, if he pulls down, the flag goes up. If he pushes up on this side, the flag goes down. And window blinds are the same. If you pull down, the window blinds go up, and vice versa. A movable pulley. This means that your rope is attached to a fixed surface, and then you pull on this side, and the pulley is kind of resting in this little divot right here. So the input is you pulling on this side, but in reality, that also means that the other side is also pulling equally. And so that means you have two input forces here, and that then means that your output force is double what your input force was. It just moves much more, or moves at half the speed or half the distance. So our mechanical advantage is increased force. Examples equal our sail pulleys. A skyscraper window washer cart works very much the same way, where one of the pieces of the pulley is attached to the top of the building, and then the person on and the pulley itself is down here on the cart, and the person can pull and raise themselves up the building slowly, but with a lot of force. And finally, we have a pulley system. The more pulleys you include, the more you increase force, but also then the more distance you have to pull in order to move an object. So the mechanical advantage of this is an increased force. You don't need to be able to draw this. You just need to know it kind of exists. And an example of this would be cranes, which are used to move huge loads. What question do the previous slides answer? All right, folks, I got a 3-question quiz for you. Pause this video and see if you can identify the mechanical advantage of these objects, and then come back. All right, what is the mechanical advantage of a unicycle? So if we look at this unicycle, we have right here the wheel and axle is what we're thinking about right here. And the mechanical advantage is going to be that we're putting our power into, or our work into the axle, and that's moving the wheel, which means that we're going to increase distance. All right, this person is cracking a walnut. What is the mechanical advantage of a nutcracker? So in this example, the person is moving their hand a decent amount of distance, and this part right here that's cracking the walnut is moving less distance, which means that its force increases. This is a bucket that gets water out of a well. What is the mechanical advantage involved? Well, right here we have a pulley, and when we pull down on this side of the rope, that's going to pull the bucket up, meaning that it changes direction. So if you answered that way, you should get 3 out of 3. All right, folks, if you have any questions, go ahead and make sure you post in our discussion forum. I'd like you to go ahead and self-assess on a scale of 1 to 5. 1 is super lost. 5 is I could build a machine right now. How well do you understand simple machines and mechanical advantage? Alrighty, folks, please make sure that you finish your diagram. If you went straight through this video and you didn't get all that down, please go back through the Nearpod, or you can view a completed version of the diagram on Schoology and use that to complete your notes. Have a great day.